Hi everyone. Good morning, good evening. Can you hear me now?
Yes.
Yes, sir.
Okay, thank you. So we'll wait for a minute. People are still joining in. So we'll wait for a minute and then we'll start the session. Thank you. Okay, so we'll get started, everyone. So before I start, I would request everyone to be on mute. So as we are going to record the session, so let's not disturb the decorum of the session. So I'll start the recording now. I hope I'm audible to everyone.
Yes.
Thank you. Hi, everyone. Good morning, good evening. Welcome to the day 2 of our exclusive training, Generative AI, AI Agents, and MCP in software testing, where we are going to learn how to leverage these elements or these techniques in the field of functional automation and performance testing. So yesterday we had the first session after the demo session, right? So as I have previously mentioned, each and every session is going to be recorded. So the recording is being shared on the next day, right? So you all are going to have the lifetime access to the videos. Whatever documents I present in the session, whatever notes, whatever scripts I prepare, everything will be shared with you all. In addition to that, I'll also be discussing, in between whatever topics I take, the interview questions, right? So before I start for the day, anyone has any queries from the previous session? So I'll take it as a no. So let me start sharing my screen, everyone.
Chandra, I have a question.
Yeah, please tell me.
Could you give example for that machine learning and deep learning? Like, what's the exact difference? I didn't get that point.
I already provided the example yesterday, right? Like in machine learning, like in your email, right? When you have some spam emails, your email client is able to detect that and is able to move it to the spam folder or the junk folder. You are not taking any action on that, right? So that is an example of machine learning. So in machine learning, this computer system, the computer machine is being, fed with input data. So it is, the algorithm is there, the mathematical model is there to understand the pattern in the data and then take some decisions without requiring explicit programming instructions while taking the decision. But it does not generate any content for you, right? But in case of generative AI, we are training the models, the mathematical models with input data. And based on that, they will interpret that, they will analyze that, they will understand that. And then the biggest positive is they are able to predict the next words, next sequences, and they are able to generate new and original content. Okay, so that is the difference. Okay, I
Okay.
hope I answered your question.
Yes, yes.
So
Thank you.
we will move to today's session. So a quick recap of yesterday's session, all of you. We went through some of the points, right? Like some thinking, some brainstorming we did, right? Then we went through artificial narrow intelligence, artificial general intelligence, artificial super intelligence, and currently we are using artificial narrow intelligence. Then we went through the key concepts and the terms, right? Like AI, machine learning, deep learning, NLP, generative AI, and language model. We also saw the difference between the different types of language models, right? A large language model and small language model, and we saw the difference between them. So let us proceed from there for today. Let me start sharing my screen. Hope my screen is visible. So everyone, I told you that like when you give some instruction, when you give some task, the AI model will be able to help you with that. I also showed some examples in the demonstration, right? I gave some instruction, I got some output. So AI is a computer machine or a system, right? So how does it basically understand us, right? So the question is, how does it understand us, all of you? We communicate in our natural language, the language which we human beings understand, right? But that language, the computer doesn't understand. Yes or no? That language, the computer doesn't understand. So, and the instruction which we give, guys, they are known as prompt. You will hear this term very often, right? Prompt. So, whenever you provide any text, whenever you provide any instruction, whenever you provide any question, right? The other day, I asked it to generate the functional test scenarios. I asked it to analyze the non-functional requirement. So I gave the input in the form of a text, human readable text, right? Very important is human readable text. What happens is when you provide that text or the input, which is known as prompt, everyone will come to that prompt. So that text or the text data is broken into tiny building blocks. Okay. So whenever we give an input, that can be in the form of a question, that can be in the form of an instruction, that can be in the form of a task, that will be broken down into tiny building blocks. Okay. Those tiny building blocks are known as tokens. So please remember this term as well. Okay. Please remember this term, tokens. Whenever we give an input, that will be broken down into tiny building blocks known as tokens. So if anyone asks you with respect to generative AI, with respect to LLM, with respect to SLM, what is a token? Token is a single distinct unit of meaning in natural language. Okay. Sorry. A humble request to everyone, guys. I have been repeating it. Let's not disturb the session. Let's be on mute. Whenever you have any queries, please feel free to unmute yourself and ask your query. Otherwise, let's not disturb the session because it disturbs the flow, right? Many serious participants are there, right? Okay, so what I was saying is when we give any input that is broken down into tiny building blocks known as tokens. So what is a token? Token is a single distinct unit of meaning in natural language. Now that, it can be a whole word. It can be a whole word. So let's say you are giving a sentence. There can be multiple words in that sentence. Each whole word can be a token. Even part of a word can be a token. Part of a word can be a token. Also, guys, a punctuation mark like a full stop, semicolon, comma, question mark, that can also be a token. Okay, that can also be a token. So tokens are nothing but bits of data. So with respect to generative AI, okay, in generative AI, tokens are the bits of data which the AI model will interpret, will process, will generate. So whenever it is taking the input, it is breaking down into tiny building blocks called as tokens. Whenever it is generating the output also, the output is also generated in the form of tokens, everyone. Okay. Like the computer understands 1 and 0, right? Any computer processing thing, whatever you take into consideration. Similarly, with respect to generative AI, that is called as now tokens. Okay, the tiny building block. So now the AI models, okay, the AI models, any AI model, guys, it is applicable to every generative AI model. All the AI models will interpret this token, means they will try to understand this token. They will process this token. They will also generate token when it has to generate the output. Okay. Now you are not going to able to see this. Whenever it is breaking down into tokens, you are not able to see this, guys. You are an end user. This process of breaking down into tokens is a background process. It is a background process. Now, how it is broken down? You would be asking, right? How is it broken down? There is a rule. There is an algorithm, predetermined rules for every model. For every AI model, there are predetermined rules. So whoever has developed that model, right, they have written the rules like how the text or the input is going to be broken down into tokens. Now, because it is, human language, right? Human language is going to be broken down into tokens. So it heavily relies on NLP algorithms, natural language processing algorithms. Yesterday, I told you, so you showed you the figure, right? Where your machine learning and your NLP, natural language processing, and generative AI, all these three are separate branches of AI, but they use, right, among themselves. Like generative AI uses NLP algorithms, it uses deep learning algorithms. Okay, so why this tokenization is being done, guys? This tokenization is done to make the whatever we are providing, it should be compatible with the AI models, right? It should be compatible so that the AI models can understand it, process it, and then generate the output also, which is in human readable form. Okay. Now you would be wondering, right? As I told you that this is a background process. This is a background process. Okay. Now the rules are separate for different AI models. So their developers have built this, they have made that models. we will see one of the tokenizer for GPT model, everyone, for OpenAI. Okay. I'll give you a glimpse so that you understand what is this, right? It will open in the browser. See, all of you, I'm taking you to the tokenizer platform. Okay, to the tokenizer platform of OpenAI. Okay, OpenAI platform. So you see here, learn about language model tokenization. OpenAI's large language models, LLMs, they process text using tokens, okay, which are common sequences of characters found in a set of text. What the model does, if they learn to understand the statistical relationship. So statistics is very, very important, all of you, in the mathematical models for the LLMs. Okay. And then they are they are excellent, right? They excel in the field of producing the next token in a sequence of tokens. They are able to predict the next sequence I was telling you, right? So now let us see, everyone. Means these all are technical things, right? So for us, the practicality is like, let's see, if I give an input, okay, explain me the, okay, before that, below, I think if anyone noticed or not, right? So before that, I need to show that. So here, all of you see, the number of tokens is 0, characters is 0. You would be wondering if tokens is equivalent to characters. Again, the answer is no. Let us see that. So if, let's say, I'm going to give one input to the model, okay, so this is about the OpenAI model. The chat GPT is a product of OpenAI, right? So explain the advantages and disadvantages of, okay, explain the advantages and disadvantages of generative AI. And I give a full stop, everyone. I give a full stop. Now I'm not going to see any output here. Here I'm trying to show you the background process. Okay, the background process. See, everyone, there are total 58 characters in this sentence. Whatever I wrote, there are 58 characters, but the number of tokens is 10. You do not ask me that how did it make that 10. So that is the predetermined rule, the algorithm which they have written, that they will not disclose to us, right? But how it has done means the algorithm we are not able to see, but how it how it makes it 10 means how there are 10 tokens. Let us see that. I hope the below text you can see now. It is color coded, everyone. It is color coded, right? So you see, explain is in a different color. Space and the is in another color. Space and advantages is in another color. Space and is in another color. Space and disadvantages. Space and off. Space and generative. Gener, right? Gener. You see here, generative is a single word. So part of a word also is a token. See, all of you, part of a word. I hope you can see that, right? It did not consider the entire generative as a single word, right? As a single token, my bad. Then ative, ATIVE is considered is another token. Space AI, see here. Then the full stop, all of you. that is in another color. So I told you punctuation mark. Punctuation mark can also be a token. Are you getting me? So you see here, this is how, based on its predetermined rules, it has converted a text which has 58 characters into 10 tokens. Is it clear?
Hello.
Okay. So all of you, this token is very, very important with respect to generative AI models. This token is very, very important. Why, you know? Now, whenever we purchase any product, right, there are certain rules based on which we need to use it. Any commercial tool, when we purchase, right, when we procure, we have a particular license, right? We have a particular license for that. These models, okay, these models have also different pricing and license, different pricing models. So how does that happen? It is based on the number of tokens also. Means, like whenever we recharge our mobile SIM card, right? When we recharge, let's say it is a prepaid. So the amount of money which we have deposited in our SIM card, right? Or the amount of money which we have recharged, we can avail that much amount only, right? Similarly, guys, whenever you go for any generative AI model, they allocate you a certain amount of tokens, and definitely that is not in thousands or 10,000s. Okay, it is normally in millions. It is normally in millions, because 1,000 tokens, you see, I just now I consumed 10 tokens. Just now I consumed 10 tokens. And remember, these tokens, right? It's not only about your input. It's not only about your input. Your input as well as the output generated by the LLM, both consume tokens. Both consume tokens, and they will be deducted from the allocated tokens to your license. That is why tokens are very, very important. We'll come to that. Okay. So, any questions on this tokenization part?
So
Very
every
good.
model has, hello.
Tell me.
Every model has different pricing, like
Yes,
for
yes. Every
tokens.
model has a different pricing. So whenever you procure any model, okay, whenever you procure any model, you will be able to get those details. So you can connect to the sales representative, or basically whenever you are working for an organization and your organization has procured any particular model, you will, as part of your license, you will be allocated a certain number of tokens, everyone. So when I'll go to the LLM examples, right, in our course content, we have that section, right, where we will go through the different models and set up. So at that time, I will basically show you the different pricing models, okay, for the different LLMs. Okay. Yeah. Any other question, anyone? Now,
Hi Chandra, I think I kept in the text as well, someone else as well, that why
okay, let me check
generative
this.
text is split it into two.
Why was this word split? That is based on the predetermined rule. They have written the algorithm that, so they will basically convert generative word into two tokens. That is their rule. That is their algorithm. Okay. Now, for example, if any other, model you go, they might have some other rules. So I showed you here that your tokens can be a whole word, part of a word also, even punctuation mark also, like full stop I showed you, right? So it depends on their rules. Okay. Fine. So my objective was to show you a practical example how this tokenization actually looks like, right? So we saw that for GPT, for the chat GPT OpenAI platform. Now remember, whenever you are dealing with generative AI models, you need to keep these two token features in mind. Okay, maximum input length. Some the LLMs, they can process certain number of tokens only in a single request. This is very, very important, guys. And this includes both your input and output. Okay, that is why we will learn prompting, guys. We'll learn the art of prompting. So it depends from LLMs to LLMs. Like every LLM will have its own maximum input length. So always check the documentation. Always check the documentation of the model which you are using. So what is the maximum input length? Then cost optimization. What did I tell you? The LLMs, the AI models, they charge, or the license which they have given, right? The pricing is based on the basis of the tokens consumed or used, right? So they charge the customer on the basis of the number of tokens which are used. So please remember, you have to wisely use the tokens. Now, like, let's say you get a pocket money, like we used to get pocket money, right? For every month. So if we run out of that, we would be in trouble, right? So we have to use it very consciously. Similarly, in this case also, you need to use your tokens consciously, efficiently. So how to do that? You have to basically understand that you simply cannot give any input to the LLM. You simply should not get any output from the LLM. You need to be very, very careful on that part. So that is why we are also going to learn the art of prompting. So how to write the prompts. So that will be so that it is brief and cost efficient. So as a result, you are able to make clear communication also, because now if let's say I ask any one of you a question, in one question, it is a very lengthy question. It is a very lengthy question. I describe a situation which is like 10, 15, sentences long. Another question which I ask is a shorter one, let's say 2, 3 sentences. Which one you will understand more effectively?
Shorter.
The second one, right, which has only 2, 3 sentences. You will understand it more effectively, and you will also process it, or you will also be able to answer it in a better way. Agree or not? So that is where this case is also similar with the LLMs. If I give a very descriptive prompt, then it is going to confuse the LLM. The communication is not going to be proper. So as a result, the output is also not going to be proper. So that is why you should always keep these things in mind, that there is a certain input length which the LLM can process for every single request. I am saying every single request. Single request means one prompt, right? One prompt is your one request. When we go to the LLMs, all of you will see that. Okay, one prompt is equal to one request. And cost optimization, right? So you need to do proper prompting. You should not waste your tokens. Okay. So if you can admit whoever is trying to join, all of you. Yeah. Then we move to the next slide. So we covered this, right? So how do these LLMs work? Okay, how do these LLMs work? Any LLM, guys, any large language model, how do they work? What happens is the LLMs try to understand the pattern and the relationship between the words and phrases. But which one? But I told you in the previous session, all of you, that the LLMs will be trained with huge, they will be pre-trained. They will be pre-trained with huge data sets. Okay. So the LLMs understand the pattern. Okay. Understand the pattern and the relationship between the words, the phrases during the training process. They learn the statistical patterns, they learn grammar, they learn semantics of our human language. Okay, using this data which is being used to train them. Now this is huge data. This is huge data. Now you just think, let's say I tell you about the freedom struggle of India. Okay, freedom struggle of India. If you take 10 books, right? If you take 10 books, 10 history books, good books, okay? Don't worry, I'm not asking you to prepare for civil services, just giving an example. So you take 10 books, okay? Read about the freedom struggle, okay? From all those 10 books. Won't you have very good knowledge about it? You will be able to process it, right? And when someone asks you about the freedom struggle, because you have read in those 10 books, so definitely you have covered a lot of stuff, right? It's very unlikely that any particular topic would be missing in all the 10 books, right? It is very unlikely. So you have almost covered the 10 books, so you know you have a very good knowledge about the freedom struggle, so you will be able to answer the questions about the freedom struggle. Similarly, here also, why we are training with huge amount of data? Because we want the LLMs to have that knowledge. Remember, the LLMs cannot learn on their own. They cannot learn on their own. They have to have data, input data. So when we give or during the training process, the mathematical models are developed which can understand the pattern and the relationship between the words and these phrases in during the training from the training data. It's not only about the data which is loaded offline or to the models. Nowadays, the LLMs are also able to scan through the internet. Remember, all of you. Okay. Initially, when they were in place, they were not, scanning the internet and all, but now they are able to scan the internet and are able to get trained, So they are able to collect vast amount of knowledge. Okay. So when they get this vast knowledge and they have the mathematical models in place, what they do, they are able to predict the next word. Okay, they are able to predict the next word. When they get the text, right? So whatever, because based on the knowledge, if they haven't learned about those, if they haven't been trained about those, they will not be able to do anything, guys. So training is very, very important. We'll come to that. Okay, means how it is important. Okay, so otherwise what problems will be there, we'll read about them. So using the mathematical calculations and the probability, they are able to predict the next word. Let us take one example. Okay, let us take one example. So guys, I hope all of you would be knowing about this game. So whoever is not aware of this, so this is a game which is very popular in Asia, England, Australia. Okay, recently we had the World Cup also. So this is a game, all of you, where we have batsman and bowler. Okay, similar to baseball. So just imagine, guys, there are 10 people. There are 10 people. Okay, 10 people. This is a group. Okay, this is a group. The question is asked to these 10 people, all of you, who is the greatest batsman in cricket? Okay, Means there is a discussion happening. They have to tell their choice. They have to tell their option. Like who do they feel is the greatest batsman in cricket? This debate happens, right, among the cricket fans. So now all of you in this forum, let's say, can some of you unmute and tell me what do you think? Who is the greatest batsman in cricket? All of you, whoever is aware of the game.
Kohli.
Okay, someone says Kohli. Very good. Anyone else?
Sachin Tendulkar.
Sachin, right? Lara, right? So let's say the first person says Kohli. Okay. Another one says Sachin. Another one, let's say, says Lara. Someone says Ganguly. Okay, someone says Ganguly. Another one says Kohli. Then Lara, Sachin. Let's say Jaisurya, right? And maybe Viv Richards, right? So all of you, what happens here now? There are two responses for Kohli. So what is the percentage? 20%, right? So K is 20%. Okay. Sachin is 2%. Sorry, not 2, again 20%. Lara is 30%. Right? Ganguly is 10%. Jaishwarya is again 10%. And Viv Richards is again 10%. So it makes a total of 100% everyone. Till now, all of you are understanding. I'm trying to explain it in a very simple way. Not much difficulties involved as far as mathematics is concerned, right? All of you agree till now? Now, as per this data, as per this information, if some layman, right, any layman who doesn't have any knowledge about cricket, guys, any layman who doesn't have any knowledge about cricket, they see this poll, okay, they see this poll, and based on this poll result, what will they say? Who is the greatest batsman? Lara. Yes? Yes or no? Clear? Now, why this happened? Because that person is a layman and simply it used this data points, this data, whatever is available as an input to that, to that person, and then based on the input, it has answered that. Similarly, all of you, if I feed this data to the LLM, if I feed this data to the LLM as a training data, okay, I feed this data to the LLM as a training data. And if someone uses that particular LLM, which has been trained on this data, and they ask the same question, the greatest batsman in cricket is, okay, the greatest batsman in cricket is, what the answer will be? Lara. Understood, everyone? However, it could be that there were better batsmen than Lara. Okay. So based on the training data, based on the input data on which the LLM has been trained, the response will be dependent on that. The response will be rather influenced by that. Okay. So the training is very, very important. The training data, the qualitative data, you need to choose everyone. All of you understood this? So the LLM basically leverages the probability. Okay, it was all about probability, right? Probability. So the LLM leverages the probability. Okay, leverages the probability to generate that text based on the data it was trained. So as I showed you, the highest percentage was of Lara. That is why if the same question will be asked to the LLM, which has been trained on that data, it will be generating the answer as Lara, because it has been trained on that data accordingly. It has been trained on that data accordingly. Okay. So because of this, there are some limitations also of LLMs, which we'll discuss. But yeah, we understood this, that they understand the pattern and then try to find out the relationships. Okay. So, but what exactly is there in the background? What exactly there is in the background? So how do the LLMs work and process our input? How do they get correct? How do they get correct? Right? The other day, the question which I gave, the use case which I gave, that there is a user field which will accept the age between 18 to 99, both included. It generated pretty good scenarios, right? And we went through those scenarios and they looked correct to us, right? They looked correct to us. Okay. So what exactly happens in the background? What exactly happens in the background? And that is basically the architecture. That is basically the architecture of the LLM. All of you clear? Okay. So that is where I'm coming now. Architecture, serial processing and parallel processing. When these LLMs came into picture, okay, when they start in the beginning, all of you, they started with the option of serial processing. What happened? They started with the option of serial processing. Okay. But with serial processing, there was problems. There were problems. How? Let me explain. When you give any input, what happens to that input, all of you? What happens to that input? That is broken down into tokens. Okay, that is broken down into tokens. I'll ask questions in between all of you, so please unmute and answer. Okay, try to make the session interactive. It should not be a one-way communication. So whenever you give any input, any instruction, that is going to be broken down into tokens. So this block, okay, let's say it represent one token, all of you. So your text is broken down into multiple tokens, let's say multiple tokens. So I'm first of all explaining about serial processing. What will happen? The LLM, okay, the LLM will try to understand and process these tokens. So because it is broken down in this manner, it will first go to this, right? Then this, because it is serial processing, all of you, serial processing, and so on. So the LLM tries to understand this first token, tries to, understand, analyze, process. Then it goes to the second one. And when it goes to the second one, it has to remember this, all of you. It has to remember this. Okay, it has to remember this because it has to, it cannot work in isolation, right? It has to generate the text or the output. So it has to understand the entire thing, right? So it first of all processes and understands the first token, then it goes to the second. So in the meantime, it remembers the second, then from the second to the third, okay, then from the third to the fourth, and let's say from fourth to fifth. Now here I have taken only 6 tokens, for example, but when there are so many tokens, right? So what happens? So I just scale it down. Let's say when it is processing the fourth token, it has tried to remember first, second, and third. Let's say it forgets it. It is not able to remember it. It is not able to remember it. The reference is lost. Similarly, when it goes to sixth, let's say it forgets second. Okay. So when it is processing serially, because there will be tokens and tokens and tokens and tokens. So what could happen is, or what actually happened is, it was losing the reference of the previous tokens. As a result, when there was huge amount of inputs or huge amount of output, the serial processing architecture was not capable basically to process that. Okay, the serial processing architecture was not able to process that. Clear, everyone? So that is why this was the demerit, and because it impacted the efficiency of the LLM, it impacted the output of the LLM. Okay, it impacted the output of the LLM. So what happened next is they went for parallel processing. They went for parallel processing. So now the same example I'll take here. Okay, same example. Let's say I have first, second, third, fourth, fifth, sixth. The LLM now is going to work on the parallel processing architecture. Again, one, two. So in the serial processing, it was processing the LLM, sorry, the tokens one after the another, right? But in I'm sorry. But in parallel processing, what it will do is it will process them in parallel. Okay. So when it is processing this token, it is also processing this token, it is also processing this token, also processing this, also processing this. Obviously, it needs higher computation resources. The resource requirements was higher in this case because processing the tokens one after the another and processing all the tokens in parallel. Definitely computation becomes more complex in the parallel case, right? We understand that. So what it was doing is when it was processing the tokens in parallel, it was trying to build the relationship of one token with all other tokens. Okay, it was trying to build the relationship of each token with every other token. So okay, then three got connected to this, and then I hope you all understand now, right? So in this way, it was trying to build the relationship, all of you. Trying to build the relationship. Okay, trying to build the relationship. So as a result, it was not losing the reference now. It is not losing the reference, the prediction of the sequences, the understanding of the sequences was more better now, more improved now in case of parallel processing. Clear, everyone? So we had serial processing, then we had parallel processing. Now, based on this parallel processing, okay, based on this parallel processing, which gave better results. The reference was not lost. The relationship was built, okay, between all the tokens. The relationship was established between each and every token in parallel. So what happened? They further took it forward, everyone. They further took it forward, and they improved. They came up with the improved architecture known as the transformer architecture. So nowadays, okay, nowadays all the LLMs are using the transformer architecture. Okay, all the LLMs are using the transformer architecture. Any questions, anyone on this slide?
Hello.
Yeah.
So when we say like the LLMs are trained on data, so Is there a specific period of data, like 1 year data, 2 year data? How much
Very good
back?
question. Very good question. I will park this question to the future session because there is an important term associated. So we'll go cover it there. But yeah, it is not basically specific to any period. It depends on the requirement. It depends on the requirement. So if I limit the LLM to a particular period, so if the question is there outside of that period, then the LLM will not be able to answer that. Yes or no? So these bigger companies, right? They have like huge training data sets, huge training data sets. It's they try to make the LLM very intelligent. They do not want to limit it. Okay.
Okay.
So there is no like one year, 2 year span is very less, very less. Okay. So huge data, huge training data, various domains. Okay, various domain. So, but yes, we'll further discuss on that in the future, like because there is an important term associated with it. Okay. So, any other doubts? Anyone? Any questions? Okay. So,
So, Chandra, I have a question.
yeah,
So LLMs like they are trained on each and everything, like means whatever the input we give.
like all the LLMs are not like that. For example, a college student, let's say they are trying to build some LLMs, they're trying to come up with some LLMs. They will not have that capability as that of, Google Gemini, let's say, or whatever, right? So it depends on that model, whatever is its objective. Okay, whatever is its objective. Like for example, like we had this company in India, right? Like Ola, right? When this AI things, started coming up, like Chat GPT. First of all, people came to know about this, like in Chat GPT and all those things, right? So when it came, this particular company, it announced its AI model. Okay, it announced its AI model. Anyone knows the model of Ola? The name of the model of Ola? Anyone? Kritim. They named it as Kritim. See, most of you also do not know because that is the condition of that model. That is the level of that model. So when they brought this, it was very poor. Poor means the answering, the response. Understood all of you? Because they just announced it. They tried to catch the eyes of the people, but it was not. So kritim means actually artificial, right? Kritim means artificial. So kritim is in Hindi, I think Hindi or Sanskrit. So artificial, but it did not match the standards. But now you see, you all recently there was the AI summit held in India, right? All of you would have, if you follow this, then all of you would have noticed that there was recently AI summit held in India. Over there, the product Sarvam AI made the headlines. This is a product of India, guys. Sarvam AI. So this is very good. Similarly, Galgotia University. This was in the news, all of you, right? What they did? They said that we are spending crores of money in our research, but they brought some, product of China and showcased it as their product. And there was a lot of backlash over it. Are you getting me? So it's not that every LLM will have every, or it will be each LLM will be good, each model will be good. No, it depends on the quality of that product also. Did I answer your question? Sorry, did I answer your question?
Yes. Thank you.
Okay. So this architecture, right? Now we are going to see the transformer architecture. So the next session, we are going to deal with this transformer architecture, everyone. We are on time today, so we'll stop the session here. We'll resume in the next one. Any questions, anyone? Thank you all for joining.
Chandra, I have a
Thank you.
question.
Yes, please.
Uh, in last lecture, you explained like there are three types of AI, like narrow and
Narrow, general, and super. Yeah.
right, narrow, general, and super. So, what is the exact difference? I didn't get between three of
Okay.
them.
So I think I explained it, but we'll take it tomorrow probably. Okay. You please
Okay,
go through the recording one more time.
yeah, sure.
But I'll explain. I'll take some 2 3 minutes tomorrow and I'll explain. Please
Okay,
ask this in the beginning of the session tomorrow. Okay.
sure. Thank you.
Yeah, because I have another back-to-back meeting, so I have to stop. I have a hard stop at 9. So
No
okay.
issues.
Yeah. So we'll stop the session here today. Hope you all enjoyed today's session, all of you. Thank you for joining.
Thank
Thank you.
Thank you.